Yes. Yes. Right. Okay. Yes. Right. Mm. Yes. Yes. Right. Okay. Yes. Okay. Uh, can someone reply? Whether you can hear me speaking properly? Quickly. Someone reply quickly. Whether everything is very clear. If you can understand what I speak. If you can hear everything properly, but reply. Everything is fine, right? Fine. Okay. Great. Okay. Great. So now I think I send the tutes, but I think but you should have received by now. If not today Sunday, so most probably you will receive the tutes on Monday. Tomorrow you will get the tutes. Okay. Uh, hands up. Did you get the tutes? Anyone already got the tutes? Hands up. If you already got the tutes, hands up. No one got the tute yet. Right. Okay. Fine. Right. Now I think last day we were discussing about liquid expansion. So we have to do few more questions in liquid expansion we'll do, but today I thought of starting gas laws. I will start gas laws today, and tomorrow, not tomorrow, tomorrow is Monday, day after tomorrow, 4th February, I might do 2 hour extra class session. Right, I did not yet decided what time I'm going to do it. Most probably it's in night. Sometimes it might be in the morning. Not decided exactly at what time I'm going to do at the extra class, but roughly think that I will do an extra class on 4th February. I will discuss more tute questions in linear expansion and applications of linear expansion and liquid expansion questions. Liquid expansion questions. Right? Okay. Right. So now today is a new lesson. If you feel that it's lagging, this video is lagging, let me know. If you feel the video is lagging, let me know, right? Let me know. Okay. So now this lesson is very new lesson. I think if you are doing chemistry, then already you might have done this section gas laws. You might have learned gas laws in chemistry also, but in physics, we go more deeper and we learn the ideas and concepts in gas laws. Right? In case if you miss the previous sections, also no issue. Right? You will be able to understand gas law section. It's a completely new and different section. Right? So I told you that last few weeks we were discussing solid expansion. Mainly, we talked about linear expansion under solid expansion. Then we talked about area expansion and volume expansion, but we could not do more questions in area and volume expansions. We will do that. Then last 2 days we discussed liquid expansion. Now you know what is a real expansion, apparent expansion of a liquid. We learned that idea also. Now today we are talking about gas laws. Gas laws mean that is basically kind of gas expansion. We learn solid expansion and also we learn liquid expansion. Under gas laws, basically, we learn gas laws only, but we can consider it as kind of gaseous expansion, right? So after completing gas laws, we are entering to most important lesson in your heat, that is calorimetry. Most important part is calorimetry. Then parallelly, I will do thermometry part. Okay, parallelly I will do thermometry part. Now put your main topic, main chapter, gas laws. Main chapter, gas laws. But until the first break, keep your focus. Until the first break, keep your focus. Main chapter, gas law. Unit 4 heat, gas laws. Right. First of all, we'll write something like this. Write down. We'll write a knot and I will describe the knot. Write down. Considering a gas containing in a vessel, consider a gas containing in a vessel. Full stop. Full stop. The gas molecules in the vessel, continue to the same line, the gas molecules in the vessel move randomly, move randomly at very high speeds. At very high speeds. Full stop. Highlight gas molecules randomly high speeds. Highlight gas molecules randomly high speeds. Next line. Next line. These gas molecules collide with each other. These gas molecules collide with each other. These gas molecules collide with each other. And with the walls of a vessel. With the walls of a vessel. Okay. So don't worry, I will explain the entire story. First of all, we'll write the knot and then I will describe the story. Next line. But when you are writing, please understand what you are writing. Try to understand. Next line, due to these collisions, comma, momentum of gas molecules change, momentum of gas molecules change. Full stop. Full stop. Next line, as a result of change in linear momentum of gas molecules. Next line, as a result of change in linear momentum of gas molecules, as a result of change in linear momentum of gas molecules, comma, forces exert on the molecules, forces exert on the molecules, therefore, full stop and continue, therefore, gas pressure forms, therefore gas pressure forms, gas pressure forms due to those forces, due to those forces. Okay, right. Now listen, now under gas laws, mainly we talk about gases. Now you know that how you differentiate gas with liquid and solid. We know that when we consider gases, the molecules are separated, because when you consider in solid, the molecules are well packed. When it comes to the liquid, molecules are packed but not like solids. But when you consider gases, the molecules are not packed. There are enough space between two adjacent molecules. Okay. And the one main characteristic of a gas is, remember, whatever the volume where we insert the gas, that gas occupies entire volume of the space. Right? Let's say now when you insert a gas into a container, that gas occupies the entire volume of the container. So that is one of the important characteristic of a gas, because we know solid has a certain volume. Right? For an example, just consider a metal cube. Metal cube has a certain volume. 5 meter cube means 5 meter cube metal volume. When you consider water also, so when you consider liquid also, liquid has certain volume, but liquid does not have a certain shape. We learned in liquid expansion, because we know that whatever the vessel that we insert the liquid occupies the shape of the vessel. If your container is cylindrical, once you pour the liquid into the container, now the liquid shape will be cylindrical. If not, if you pour the liquid into a cuboid container, the shape of the liquid will be cuboid. So liquids, remember, they have a fixed volume, but liquids does not have a fixed shape. But when it comes to gases, remember, gases does not have a fixed volume. Whatever the volume that you insert a certain gas, that gas obtains that entire volume. For an example, remember, understand. Now there is a just think there's a container. There's a container. I say this container volume is capital V. And you insert a gas sample of mass, let's say 2 grams. You insert 2 grams of gas mass in this container. Remember that gas occupies this entire volume of the container. If I ask you what is the gas volume in the container, gas volume in the container is volume of the container, capital V. Red color dots are the gas molecules. Now, the same 2 grams of gas sample, if you insert to a larger container, this container volume is V. What would happen when you insert the same gas sample? same gas mass to a large container. Again, that 2 grams of same gas sample obtains the entire volume of the container. If I ask you what is the gas volume, the gas volume is the volume of the container. If I say this volume is 5e, when you insert the same gas sample, it obtains the entire volume of the container. So understand, this is one of the important points that you should keep in your mind. In questions, they don't give the volume of the gas, but they give the volume of the container, right? Now, next important thing you should understand in gases, how this gas pressure forms. What does it mean by gas pressure? Now, you know already from the mechanics knowledge, we know that pressure means we defined. How did we define pressure? We know pressure means force over area. In hydrostatics, we learned pressure as what? H rho g. Hydrostatic pressure means H rho g. First, you should have an understanding about how when you insert a gas in a container, how there is a gas pressure forms. How there will be a gas pressure forms in a container. That is first important idea. Just consider this container. Now, you insert a gas sample into this container. Just when you consider the gas molecules, these molecules undergo kind of random motion, right? If you consider the speed of gas molecules, they move with different speeds with different directions. So you can't predict the direction of each gas molecule. So they move in random directions with very large velocities. Then what would happen in a traffic? Let's say now the vehicles, rather than moving vehicles in a straight line, what would happen in a traffic road if the vehicles start moving randomly? Definitely vehicles start collide with each other. Very similar thing happens in this gas sample in the container also. When they move in random directions with very high speeds, these gas molecules collide with each other, as well as gas molecules collide with the container wall. So we can identify two types of collisions. One is a gas molecule collide with each other. Other type of collision is gas molecule collide with the container wall. Okay. Just consider only one gas molecule colliding on a container wall for our understanding. Because I'm going to explain how this gas pressure forms in a container. Now, this is my wall. Very carefully listen. I'm going to consider motion of one gas molecule. This is my container wall. Just assume a mass of one gas molecule is simple lim. This gas molecule mass is simple lim. Now, this gas molecule was moving with a velocity of, let's say, capital V in this direction. Its velocity is capital V. I say the angle. If I say this angle as theta, then you know that in linear momentum, you can remember what is linear momentum. You can remember linear momentum means we learned in mechanics, unit 2, linear momentum means the multiplication of mass into velocity. Remember, linear momentum is a vector. Capital P means the multiplication of mass into velocity. Linear momentum is a vector. What is the direction of linear momentum? Direction of linear momentum is always in the direction of velocity. These ideas we learned, right? And also, can you remember in unit 2, we learned, can you remember how we define the Newton's second law? Newton's second law, you can remember, right? We learned in unit 2, Newton's second law. What is the Newton's second law? Can you define? The external unbalanced force directly proportional to the rate of change in linear momentum. Now, those previous theory ideas really important to explain how gas pressure creates in a container. So therefore, keep your focus. Now, in Newton's second law, you learned Newton's second law. You learned the external unbalanced force acting on an object is directly proportional to the rate of change in linear momentum. Capital P means linear momentum at a certain instant. Delta P means change in linear momentum. When you divide change in linear momentum by the time, that is what we call as rate of change in linear momentum. Newton told that the external unbalanced force acting acting on an object equals its rate of change in linear momentum. Further, you derive not only external unbalanced force equal to rate of change in linear momentum, but also that external force exactly equal to rate of change in linear momentum. This idea you learned. From this equation only, we derive F equals me. From this equation only, we derive F equals me. Delta P or delta T equation only, we derive F equals me. We learned this story. And also, you know that in hydrostatics, you learned pressure means, basically pressure means the perpendicular force acting per unit area. So these are the previous knowledge you need to understand today's lesson. Right? How do we define pressure? The force perpendicular to unit area. Okay, now we'll come back to the story again. There is a gas molecule, its mass is simple m. Now it is moving with a velocity of v. Now we can understand this particle is going to collide with the wall. What would happen for the particle as soon as it collided with the wall? Just assume it changed the direction. It changed the direction, but assume now that particle is leaving with the same velocity v. Okay. Assume it's leaving with the same velocity and same angle. Now, due to this collision, basically, what happened to the particle? Now, this particle collided with the vertical wall. As a result, what happened to the particle? Its linear momentum has changed. Why? What is the magnitude of the linear momentum before collision? mv, mass into velocity, mv. What is the magnitude of the linear momentum after the collision? m into v, mv. Yeah, magnitude of linear momentum is same, but direction of linear momentum earlier was this direction. Now direction of linear momentum is in this direction. So very clear, since linear momentum is a vector, linear momentum has changed. Whenever linear momentum changes, I told you, some kind of resultant force exerted on the particle. Some kind of resultant force exerted on the vertical wall. We learned. Shall we find first now to revise the things, shall we quickly find the change in linear momentum acting on the particle? Right? If I find the change in linear momentum acting on the particle, you know that we want to consider, if I try to find the change in linear momentum in this direction, we have done this question before also, horizontal direction, then we know change in linear momentum means final linear momentum minus initial linear momentum. Final linear momentum minus initial linear momentum. What is the final linear momentum in this direction? If you resolve linear momentum into two perpendicular components, horizontal component and vertical component. What is the horizontal linear component? What is the final horizontal linear momentum? mv cos theta. So this direction we know mv cos theta minus initial linear momentum is horizontal initial linear momentum is mv again cos theta, this direction. Left side direction mv cos theta. We learned the story, when arrows are in different directions, we can't do the addition or subtraction. If you want to continue addition or subtraction, we learned that you want to bring, first of all, you want to bring both of the arrows in same direction. So I thought of change this one's direction. mv cos theta minus, if you change this one's direction, now its direction is right side, but you want to put a minus. We learned this story. mv cos theta minus become plus. Finally, you get the change in linear momentum in this direction will be 2mv cos theta. Raise your hands. Up to now, story is clear, but still I didn't explain how gas pressure forms in the container. So far, everything is very clear. Raise your hands. So far, the story is very clear. Raise your hands. If you understood the story, raise your hands. Very clear. Okay. Now I found the change in linear momentum in the horizontal direction. But I want to find the change in linear momentum in the vertical direction as well. Then again, you find the change in linear momentum in vertical direction. Now keep your focus. Now the story is not important to understand today's lesson, but if you understand this lesson, this part, You can feel this part very clearly. That's why. If I find the change in the momentum in vertical direction, upward direction, right? Then I consider down direction. The final vertical leading momentum will be mv sine theta. Downwards, mv sine theta minus initial. Initial vertical leading momentum will be mv sine theta downwards. Downward, mv sine theta. So you understand now arrows are in same direction, downward, downward. Therefore, you can subtract mv sine theta minus mv sine theta means we know that is 0. So we notice there isn't any change in linear momentum in the vertical direction. So the overall change in linear momentum is 2 mv cos theta. 2 mv cos theta. I told you, Newton told that whenever there is a change in linear momentum, Newton told there should be a resultant force acting on the particle. We noticed linear momentum of the gas molecule changes. That means resultant force has acted on this gas molecule. Okay. Resultant force has acted on the gas molecule. Shall we find the resultant force? Because we know that capital F means we know delta P over delta T. What is the change in the momentum in this scenario? 2 mv cos theta. 2 mv cos theta. Let's say the time of collision. Just consider delta T, and then this will be the resultant force. Now I think you understand whenever a force is acting on an area, then there's a pressure. So story is very simple. Story is we noticed when you insert a gas in a container, that gas molecules move in random directions with different high velocities, high speeds. As a result, they collide with each other as well as they collide with the container wall. When they collide, we noticed its linear momentum changes. As a result, there are forces acting on the molecules. When those forces acting in the area, there is a pressure. There's a pressure. So basically, remember, gas pressure creates due to the collision of gas molecules. Raise your hands. How many of you understood how this gas pressure forms genuinely? If you understood how this gas pressure forms genuinely, raise your hands. Very clear. So what you do, you take time. Don't take so much of time. No, roughly write down these things. Not that much important. No, it's important also. But just quickly write down this diagram. Then I have taken only one gas molecule and the container wall, gas molecule defined. Container wall, gas molecule defined. Some additional note. You should know. You should learn these things before. Additional note. This story. Once you finish writing, raise your hands. Once you finish writing, raise your hands. So break will be we started at 7, let's say 7:15, 8:15, 9:15. Break will be at 9:15. If you finished writing, raise your hands. If you finished writing, raise your hands. Okay, right. So then we understood how gas pressure forms in a container. It's very clear. Then write down like this. Then write down. Uh, write down. In order to indicate the physical state of a given mass of gas, write down. In order to indicate the. In order to indicate the. In order to indicate the physical state of a given. Physical state of a given physical state of a given mass of gas, comma, comma, its volume inside the bracket capital V close the bracket, its volume inside the bracket capital V close the bracket, comma, pressure inside the bracket capital P close the bracket, and temperature inside the bracket capital T close the bracket, can be stated as parameters. Can be stated as parameters. Okay, I will explain, don't worry. Next line, write down next line. Gas laws are built up. Gas laws are built up using the relationships between volume, comma, pressure and temperature, V, comma, P and T. Gas laws are built up using the relationship between V, comma, P and T to explain the behavior of a to explain the behavior of a to explain the behavior of a constant mass of a gas. Constant mass of a gas between two states. Between two states. Okay. Now in this lesson, we learn about the behavior of gases. How this gas behave, how these gas molecules behave. What would happen for its pressure? What would happen for its temperature? What would happen for its volume? Basically, our goal is to understand the behavior of these gas molecules. In order to understand the behavior of gas molecules, we take three main parameters. Right? We take three main parameters to understand the behavior of gas molecules. We have to consider three main parameters. That is volume of the gas sample, and next one is temperature of the gas sample. The last one is pressure of the gas sample. You know what is temperature? Measured in Celsius or Kelvins. The volume measured in meter cube, centimeter cube, liter, milliliter. Pressure measured in Pascal, unit per meter squared. But understand, basically what we do in this lesson, if for a given gas mass sample, remember what we do in this lesson, every gas law what we analyze for a given gas mass, for a given gas mass, we talked about two different states. Okay, we are now, the story is our target is to understand the behavior of gas molecules. Then we consider these three parameters, but remember we should maintain gas mass as constant. For a certain gas mass between two different states, you are going to check the relationship between volume, temperature, and pressure. For an example, just consider there is a gas sample. This is my gas sample. Its mass is fixed. You want to ensure same constant mass throughout the two different states. Let's say at the state 1, in the state, I say pressure of the gas sample is P1, corresponding volume of the gas sample is V1, temperature T1. So then due to the some changes in pressure, volume and temperature, let's say this is the second state of same gas sample and same mass. You want to ensure same mass. If not, we can't do the analyzation. If not, we can't do this, we can't understand the gas behavior. So now pressure is P2, now volume is V2, now temperature T2. We are going to analyze how these parameters vary when you maintain a same gas sample, when you maintain same gas mass in two different states. Now, first of all, now we should have an idea about the pressure. Now you know what is gas pressure, and write down units of gas pressure. Now, if you want to draw this diagram, you can draw this diagram and write down units of gas pressure. What is the SI unit to measure gas pressure? We know SI unit is Pascal. Write down units of gas pressure. We know SI unit is Pascal. That is pascals. But we know there are other units. Write down other units. Other units. What are the other units? Mercury millimeters. We know mercury millimeter is a unit to measure pressure. And also we use mercury centimeters and mercury meters. Right? Mercury meter, simple lim H2O. Sorry, mercury meter, simple lim capital H. There are other units. Water meter. Water meter, MH2O. This is also kind of unit to measure pressure. Then ATM, not that ATM, ATM, and then the bar, BAR bar, and then TOR, TORR, TORR. So SI unit is Pascal. If not Newton per square meter, there are other units as well, millimeter, mercury centimeter, mercury meter, water meter, ATM bar, TOR. Then sometimes in exam in MCQ, they can give a pressure of a gas in mercury millimeters. Then you should be able to convert mercury millimeters into pascals. If not, they might give the pressure as water meters. The pressure of gas sample in a container is, let's say, 20 water meter. Find the gas pressure in Pascal. Then you should be able to convert a given pressure from one unit to other unit. Now write down important. After writing this important, write down. Important, write down. How do you convert if they have given pressure in bar? How do you convert to pascals? In case if they have given pressure in bar, if you want to convert to pascals, SI unit, remember you want to multiply by 10 to the power 5. You want to multiply by 10 to the power 5. Should multiply by 10 to the power 5. Then if they have given out, this is what they normally ask. They give the pressure in bar. You want to find the corresponding pressure in pascals. But sometimes they don't ask. If they have given the pressure in Pascal, if you want to convert to bar, then you should multiply by 10 to the power minus 5. That story I'm not explaining. That is one point. Let's say if they have given the pressure in ATM, if they have given the pressure in ATM, and if you want to convert to Pascal, Remember, you want to multiply by 1.01. You want to multiply by again 10 to the power 5. You want to multiply again 10 to the power 5. Remember, 1 ATM means, remember, normally the exact value of 1 ATM is 1.01, 1.01, 325 into 10 to the power 5 pascals. But you understand, 1 ATM means 1.01325. But we can approximately equal this value to what? 1 into 10 to the power 5 pascals. That's why I told you, if they have given the pressure in ATM multiplied by 10 to the power 5, then you can get the Pascal value. Pascal value. So you keep on write with me. You keep on write. Because every point is something different part. Okay. So next, how do you convert if the pressure is given in mercury millimeters, and if you want to convert to mercury meters? Next one is, how do you convert if they have given pressure in mercury millimeters? Pressure is given as mercury millimeters, and you want to convert into mercury meters. How do you convert? How do you convert millimeters into meters? Multiplying by 10 to the power minus 3. The same story is applied in this case also. If they have given the pressure in mercury millimeter, if you want to convert to mercury meter, multiply by 10 to the power minus 3. Next one. Now keep on writing, not difficult stories, but easy stories. Huh? Now, if they have given mercury centimeters, if they have given mercury centimeters, if you want to convert to mercury meters, how do you convert to mercury meters? Again, how do you convert centimeters into meters? Multiply by 10 to the power minus 2. Then same story, if you want to convert mercury centimeters into mercury meters, multiply by 10 to the power minus 2. In case if they have given the pressure in mercury meters, if we want to convert to pascals. Now they have given pressure in mercury meters, but you want to convert to pascals. How do you convert? Remember, you want to multiply by rho g. Rho g means, rho means density of the mercury, g means gravitational acceleration. So this part is also taught in hydrostatics. Now these days, now we are now 25 theory students have free access to 26 theory classes. If you could not cover that, then join the 26 theory classes. You have full access. You can access the recordings. You can join live classes, because you only have to do the 25 theory online class payment. Then that payment slip upload in 26 theory class also. Then you will get the access for both 25 theory and 26 theory. And also 25 paper class students get free access. 25 theory class students get 50% discount to 25 revision paper class also, because definitely you have to enroll for 25 paper class, because still papers are not yet started. Most probably in the mid of February, if not in the beginning of March, we will start doing full papers also. So then definitely you have to join. Since you join my theory class also, I thought of giving kind of a discount of 50%. Okay, right. So how do we convert mercury meters into pascals? How do we do this one? Now, remember, if you want to convert mercury meters into pascals, you want to multiply by, remember, density of mercury into gravitational acceleration. Rho hg into simple g. If not, I will write down. What is the density of mercury normally? Density of mercury is 13,900, right? Density of mercury is, remember, 13,900, sorry, 13,600. Density of mercury is, remember, 13,600. Gravitational acceleration is, remember, 10. This is a story. This is important. So highlight this conversion. Then you should be, then if you know the conversion mercury meters to Pascal, if they have given in a question, you to convert mercury millimeter to Pascal, you should know how to do that. I can't, it's a separate point. I taught you how to convert mercury millimeters to meter. You know how to convert mercury meters to Pascal. If they have given you to convert mercury millimeter to Pascal, you should know the idea. You should know the idea. Okay, right. And the last one is, remember, if they have given water meters, mercury meters means Hg simple name, water meters means H2O simple name. H2O. And if you want to convert to Pascals, remember, you want to multiply by rho water, rho W, density of water into gravitational acceleration. Okay. So density of water, I write it as rho W. Now normally it's 1000 kg minus 3. Density of water is 1000 normally. That means 1000 into 10. This is the story. Quickly convert this SQ1, sample question 1, write down. Sample question 1, write down quickly. Sample question 1, SQ1, write down quickly. Do below conversions. Do below conversions. Do below conversions. Okay, quickly convert this into Pascals. Convert this into Pascals. Number 1, 5 mercury meter to Pascals. Number 1, 5 mercury meters to Pascals. Then number 2 is 25 mercury centimeter to Pascal. The last one is 100 mercury millimeter to Pascal. Not difficult story. Third one is 100 mercury millimeter to Pascal. Do them. Find them. Once you finish doing, raise your hands. Once you finish doing, raise your hands. Once you finish doing, raise your hands. This is very important part. Gas laws, it's very important part. Really important, because there will be around 2 MCQs coming from this part, 2 MCQs. Right, we can't show the essay question from gas laws, but generally, because in unit 4 heat essay question, they can ask gas law essay question. If not, they cannot ask. But MCQs, there are 2 MCQs coming from this part. One, there are some practicals related to this also. There are, I think, around three practicals related to gas laws. Right. So once you found these 3 values, raise your hands. Because if not, I don't know whether you finished writing or not. I don't know. I don't know. I don't know. Quickly. If you finished, raise your hands. Not difficult. Easy. Now see, little by little, we are developing a theory. Slowly but properly, by taking time, detailedly, we do the discussion. Right? Any levels of student can understand the story. Any level. Finished, right? So this is, now I don't want to do these things, but to get a kind of idea, I'm doing. Okay, if I convert the conversions. Now millimeter to Pascal means we know how to do this one. So what do you want to do? So you know that millimeter to Pascal. Then multiply by density of what? Mercury into 10. 5 into density of mercury means 13,600 into 10. So then you simplify this, you get the answer in Pascals. Now, if you want to convert 25 mercury centimeter into Pascal, first of all, try to convert 25 mercury centimeter into mercury meter. Then how do you convert mercury centimeter into mercury meter? Multiply by 10 to the power minus 2. Now this is in mercury meters. How to convert it into Pascals? multiply by density of mercury into gravitational acceleration. Then you can get the answer in pascals. Not difficult. Then in this scenario, first of all, now they have given mercury millimeters. If you want to convert to if you want to convert to pascals, first convert this into mercury meters. Then you can convert to pascals. How do you convert mercury millimeter to mercury meter? Multiply by -3. 100 multiply by -3. Then you can obtain pressure in mercury meters. How do you convert mercury meters to pascals? Multiply by density of mercury, 13,600 into 10. 13,600 into 10. Then this answer also very clear. This answer also very clear. Pascals. I don't simplify. You go home and simplify it. That story also finished. Finished. So then what have we discussed so far? If we brief it. So we took 1 hour and what have we discussed so far? Now, first important thing is in this lesson, we learn about gases. Then first you should understand whatever the volume that we insert the gas, that gas occupies the entire volume. Next point is you should understand how the gas pressure forms in the container. We did a detailed description. Then if we did some conversions. We talked about units of pressure. Then if they have given in different units, how do we do the conversion? We have the basic understanding. I think everything is very clear. Now we are talking about gas laws. Now we are going to talk about gas laws. Now torr is also nothing but one. Now they don't give in exams. One torr means again it's about 5 pascals. Same story. Torr, bar, ATM, everything is same idea. Same idea. Okay. So now put your main topic. Now we are going to learn about first law in gases. Main topic write down. Main topic write down. Main topic Boyle's law. Main topic is Boyle's law. BOY boy, LE Lee. What apostrophe? What's that? Apostrophe? I don't know. Something. S Boyle's law. Boyle's law. It's Boyle's law. Main topic. Boy, Lee, Boyle's, not Boyle's law. Boyle's law. Right. Red color pen, write down. No. Take your blue color pen and write down. Blue color pen. This is the law. Huh? We are writing a law. Law is a law. We can't argue behind. That's why we named it as a law. Law means law. We can't argue. No, that can't be right. This can't be right. We can't. It's a law. Someone explained a law. That law is accepted by the world. Now we have to follow that law. We can't break that law. Red color pen, blue color pen, write down. Boyle's law states that. Boyle's law states that. Boyle's law states that. Red color pen, write down. Red color pen. The volume of a stationary gas mass. The volume of a stationary gas mass. The volume of a stationary gas mass at constant temperature. At constant temperature. Is inversely proportional to the. Sorry, is inversely proportional to its pressure. Is inversely proportional to its pressure. Full stop. Full stop. Okay. Right. Now quickly do this diagram. Start drawing this diagram. Okay. Just draw piston. Start drawing this piston. there is a gas inside the piston. Why I'm taking a piston rather than a fixed container? The reason is sometimes due to the change in parameters of temperature, volume, and pressure. Sometimes what will happen? The volume of the gas should change, right? Because we know piston is some kind of container which is flexible to change in volume. That's why when I explain the story, I drew a piston, but it's not compulsory to draw a piston. You can use a container row, you can use whatever. Okay. Now there is a gas inside the container. First of all, in this piston is my gas. First of all, we'll define what is simple M, what is capital T, and what is, you know those. It's volume, pressure, everything you know. But as a theory to maintain a good note, write down simple M means simple M, capital T, capital P, capital V. So write down what is simple M. Write down what is simple M. Simple M means write down mass of gas sample. Simple M means write down mass of gas sample. Simple M means write down mass of gas sample. Capital T write down. Capital T write down. Capital T write down. Capital T write down. Temperature of gas sample. Temperature of gas sample. Capital V, volume of the gas. Capital V, volume of the gas. Capital P, pressure of the gas sample. Pressure of the gas sample. Okay. Okay. Right. Now, now basically Boyle's law states what? Boyle's law is applicable. Boyle's law is valid when the gas sample's mass is constant and the temperature of the gas sample is constant. You want to ensure mass of the gas sample is constant, mass is fixed, and the temperature at which gas exists should be fixed. Remember, mass and temperature should be maintained at constant values. Mass and temperature should be maintained at constant values. Okay. So now they tell the story. They are telling when mass and temperature are constant, mass is simple M, temperature capital T. Now these two constant. Temperature you want to ensure 50 Celsius for an example. Mass of the gas sample is always 5 gram means 5 grams. It can't go, it can't deviate. If you maintain these two parameters constant, they tell a story. They say that pressure of the gas inside the container inversely proportional to the volume. If you can maintain in a gas sample mass and temperature constant, pressure of the gas is inversely proportional to the volume. What is the meaning of inverse relationship? When you increase the volume, your pressure decreases. So that is what we call as inverse relationship. When you increase the volume, pressure should be decreased. When you decrease the volume, pressure should be increased. That is what we call as inverse relationship. Now this Boyle told that when you maintain mass and temperature constant, pressure of the gas inversely proportional to the volume of the gas. What is the meaning? When you increase the volume of the container, what would happen for the gas pressure? Automatically gas pressure decreases. That's why I'm using a piston. Because since it's a piston, when I move this arm into the right side direction, what would happen for the volume of the piston? Increases. If the volume of the piston increases, if you maintain constant temperature, and same mass, what would happen for the gas pressure? Decreases. Story is very clear, very simple. To remove this proportionality, we are using constant. We can tell then pressure equals that constant is capital K, dot 1 OV. 1 OV. 1 over V. So you can keep this as your equation. If not, generally what we do, I bring the volume to right left side. Then pressure into volume is always a constant, right? So the basic rule is when you maintain mass and temperature constant, pressure is inversely proportional to the volume. If not, I can tell if you maintain mass and temperature constant, multiplication of pressure into volume is always a constant. See, we can tell the same law in two different ways. Equals K. Raise your hands. Up to now, everything is very clear answer. Everything is crystal clear answer. Everything is crystal clear answer. Everything is crystal clear. No issues, right? Okay, great. So then write on this and highlight this. Highlight this one. Now you can learn this section as a new section. Okay, it's very new section. And gas laws part is very interesting also. I also like gas laws part personally. If you finish, please raise your hands. If not, I don't know whether you finished or not. If you finish, raise your hands. But that story I told you in the beginning, I told you always volume of the gas means volume of the container. Because you know gas occupies the volume of the container. Red color pen write down. Red color pen write down. Always volume of the gas equals to. Always volume of the gas equals to volume of the container. Always volume of the gas equals to volume of the container. Right. But generally now we don't get this equation to apply in our questions. In questions, what they do, they tell that nitrogen gas, oxygen gas, argon, whatever gas, they tell that mass and temperature of a gas is constant, and they give pressure and volume at two different states. They tell that in a question, argon mass and temperature constant, pressure and volume in state 1 is, let's say, 502, and they give pressure in second state is 900. They ask you to find the corresponding volume in second state. So then this is the law, this is the thumb rule, but we are going to modify this thumb rule to two different states of the gas. Same gas sample at two different conditions. Two different conditions means they are at two different pressure and volume values. Because we know if you maintain empty constant, who is going to change? Pressure and volume is going to change. So in state 1, in the state 1, pressure and volume will, let's take V1 and P1. In the second state, pressure and volume will be P2 and V2. So we are going to build a relationship between P1, V1 and P2, V2. Okay, write down a topic. Write down a topic. Write down. Applying Boyle's law for two states of a stationary gas sample. Applying Boyle's law for two states of a stationary gas sample. Stationary gas sample. Okay. Right. So now we'll derive it. Okay. Now again, we'll draw the two pistons again. State 1, state 2. Draw two pistons. So you also keep on drawing with me. I don't give time. Draw with me. Two pistons. And the temperature is capital T. Mass is simple M. Corresponding pressure and volume will be P1 pressure. Volume is V1. Okay. So there is a gas inside this vessel, inside this piston. So that is my state 1. That is my state 1. Okay. Now in my state 2, what will happen? In my state 2, In my state 2, still you maintain same gas inside the piston and the same temperature. But in state 2, pressure is P2, volume is V2. So write down this as state 1, this as state 2. Okay. Now what can you do now? Now what can you do now? Now you can apply. Now I'm going to build a relationship between P1, V1, P2, V2. If you know the story, you know that no doubt always pressure into volume is constant, means you can directly tell P1, V1 equals P2, V2. But as a theory, we are building properly the theory. Therefore, you want to do everything properly. So what you can do, you can consider state 1, you can apply Boyle's law. Right? State 1, you can consider state 1. Okay. State 1, apply Boyle's law. Applying Boyle's law. BOI, Boyle's law. Then you know that pressure is P1 into volume is V1. This must be equal to a constant, that is K. I take this as equation Roman number 1. This is my equation Roman number 1. And again consider state 2. State 2, apply Boyle's law. Then you can write down. Pressure is P2. If you apply this equation, P2 V2 equals K. That is my Roman number 2. Roman number 1, Roman number 2. Then finally you can write down. From Roman number 1 and Roman number 2, we can write down. From Roman number 1 and Roman number 2, we can write down P1 V1 means P2 V2. This is what we always use in the equation. We compare two states. And we apply the equation. So you can write down P1 V1 equals P2 V2. Finally, you are getting P1 V1 equals P2 V2. Story. Done. That's it. See, not difficult. Not difficult. Finish writing answer. Write down a note. Write down. Not sample question, SQ. SQ write down. Sample question, SQ write down. The pressure and volume of hydrogen, because you know hydrogen means H2 gas. The pressure and volume of hydrogen in a container at a fixed temperature are 4,000 Pascal and 5 meter cube. 4,000 Pascal and 5 meter cube. 4,000 Pascal and 5 meter cube. Full stop. When the volume is increased by, very carefully understand the English. When the volume is increased by the amount of 5 meter cube. Increased by the amount of 5 meter cube. Previous volume is 5 meter cube. Now its volume is increased by the amount 5 meter cube. Then always check what does it mean. When the volume is increased by the amount of 5 meter cube, comma, then find the pressure in the container. 1 minute, quickly. Then find the pressure in the container. 1 minute, quickly. Raise your hands, finish doing. Quickly. It won't take so much of time. Raise your hands. Finished. If you finish, raise your hands. It won't take so much of time. Not difficult. Finished, right? So SQ. So you want to apply P1 equals V1, P2 equals V2. Story is very simple. So you can tell, you want to tell down Boyle's law. From Boyle's law, you want to write if you are doing in essay, from Boyle's law, you want to mention. So P1 V1 equals P2 V2. Right? Right? So what is P1? P1 value is how much? Pressure. Pressure given as 4,000, corresponding volume is 5 meter cube. So 4,000 into 5 must be equal to, I want to find the new pressure. If a pressure in the state number 2, but the volume is increased by 5 meter cube. Previous volume is 5. Now its volume is increased by 5 meter cube, means now volume is how much? 10. I want to find P2 only. I want to find P2 only. Now volume is how much? Now volume is 10. So answer is very simple. Answer is how much? Now pressure is how much? P2 will be equal to 2000 pascals. Right? P2 will be equal to 2000 pascal. 2000 pascals. Now write down main topic. So we will do good question in the tute. I think I have shared the PDF, but you will get the tutes also. Okay, today let's see whether we want to take the PDF or not. We'll see. Put your main topic. Graph related to graphs, plural. Graph related to Boyle's law. Graph related to Boyle's law. Graph related to Boyle's law. Okay. Okay, now always keep your focus, right? Now this one, now only we start the class at what, 7:50. Now time is 8:30. 1 hour and 15 minutes continuously we learned. I think up to now story is very clear. Until class finishes, somehow keep your focus. It is with your hand. It isn't with your hand, right? So number one, write down number one, first graph between pressure and volume, between P and V. First type of graph, write down between P and V. Between P and V. So take your y-axis as capital P and take your x-axis as capital V and draw the graph. Y-axis take as P, x-axis take as V and draw the graph. Draw the graph. Capital V. Quickly. So then you know that I told you in the beginning, this law directly depicts that pressure is inversely proportional to the volume. What will happen when volume increases? When volume is increasing, your pressure must be decreasing. When volume increases, pressure must be decreasing. Okay. So therefore, if you draw the graph will be, you can draw the graph also. I think chemistry also you might have learned. The graph would be something like this. Kind of inverse proportionality. It's not touching. So then I will show you some idea. Let's say now, when the volume is V, for an example, when the volume is V, I take the corresponding pressure as P. Then I want an answer. Put the answer in the chat box. When the volume is 2V, what is the corresponding pressure? Reply quickly. Put in the chat box. When the volume is V, corresponding pressure is P. When the volume is 2V, what should be the corresponding pressure? Always you know PV is a constant. What is the answer? Reply in the chat box. P by 2. P by 2. Because you know that always multiplication is a constant. initial case, volume is V, pressure is P, PV, PV. In the second scenario also, when you multiply the pressure and volume, must be PV. This time volume is 2V. In order to get PV as final answer, your pressure must be P by 2. That is the first graph, understood. Graph number 2, write down. Graph number 2. Graph number 2, write down. Between P and 1 OV. Graph number 2, between P and 1 OV. Now, this is P and V. Number 2, P and 1 over V. This one. Draw the graph. P and 1 OV. How do you draw the graph? Draw it. Then take your y-axis as capital P, x-axis as your 1 OV. Y is capital P, and your x is 1 over V. So now in this case, what you can do, you can take something like this. Look here. You can take, we know that the equation P equals what? K over 1 over V. Sorry, P equals K into, you know that. P equals K into 1 over V. Am I correct? Am I correct? This idea you can understand, right? P equals K into 1 over V. So who is your y-axis? Your y-axis is P. And who is your x-axis? 1 over V is your x-axis. Then, who is your gradient? It looks like K is your gradient. It looks like K is your gradient. Then this graph follows y equals mx graph. K looks like gradient. It follows y equals mx graph. Y equals mx graph. Then the graph would be like this. Graph number 2 also done. Graph number 3. Graph number 3, write down. Graph number 3. Graph number 3, write down. Between PV and V. Graph number 3, between PV and V. So y-axis take it as PV, x-axis take it as V. If you take third one, between PV and V. Between PV and V. In this case, your y-axis P into V, your x-axis is V. So you know that no matter when volume increases, no matter volume changes, do you think your multiplication of PV change? No. Boylston tell that multiplication of PV is always constant. Multiplication of PV is always constant. When you increase the volume, remember, in order to maintain PV constant, pressure decreases. When you increase volume, remember, in order to maintain PV constant, pressure decreases. Ensure multiplication of PV means always constant. So therefore, it doesn't matter when you increase the volume, always PV is a constant. Graph number 3. The last graph, write down. The last graph. Graph number 4. Not last graph, I think it is fourth graph. Between PV and P. This is PV and V. When you draw PV and P, between PV and P. Between PV and P. Quickly draw the graph. Between PV and P. Between PV and P. Draw the graph. Between PV and P. Graph number 4. Between PV and P. Between PV and P. Right. So here, your y-axis is what? Y-axis PV. What is your x-axis? That is V. So that is P. In this course also, it doesn't matter when your pressure increases or decreases. Always remember multiplication is a constant. When you increase the pressure, what will happen? Parallelly, volume decreases, ensure multiplication of PV is a constant. So if you draw the graph, again, it's a constant line. It's a constant line. The last graph, write down between log P and log V. Between log P and log V. The last one, fifth one, between log P and log V. LOG, log, all match, log P. Between log P and log V. Now, I think most of you can't derive this one because still you don't have any experience. Sometimes you can't do this, but that's okay. That's okay. Look here, I will explain. Now, I think most of you can draw, I think, graph number 1, 2, 3, 4. I think you can do it. Okay, I will give some time. Shall I give some time you guys to try the graph? Shall I give some time to hands up? Who needs some time to try the graph? Hands up. If you need some time to try the graph, this one hands up. Okay, I'm going to do it. I'm going to do it. Carefully listen. Right now, first of all, you should now we know the equation. The Boyle's law, the equation is this is the equation PV equals K. This is the main equation. But first of all, if you want to plot a graph between log P and log V, first you should find an equation involving log P and log V. But the equation that we know does not involve any log values. It is says that PV equals K. Then somehow you should convert this into log P log V equation. I am taking that equation PV equals K. PV equals K. What I do, O level maths you might have done, you can take log in both sides. If you take log in both sides, you can multiply both sides by same value. Likewise, you can take log in both sides. When you take log in both sides, you can write down this as log PV equals this as log K. Am I correct? Can you remember in O levels, log P into V means we can write down. Log P into V means you learnt in O levels, we can write down log P plus log V. Am I correct? Log P plus log V must be equal to log K. And now finally I converted the equation in terms of log P and log V. Yes, finally I obtained this equation in terms of log P and log V. Yes. What is my y-axis? Take your y-axis as log P and take your x-axis as log V. Then how you do this one? Right. Then we'll take a small break and we'll start Charles' law. Now, who's my y-axis? Log P is my y-axis. Log P is my y-axis. Log V is my x-axis. Then draw the graph. Now you can draw the graph. Now it's not difficult. So I am subjecting log P. Then we know that log P equals minus log V. If I move log V to the left side, right side, minus log V plus log K. Plus log K. Then it's like, it seems like this is Y minus, this looks like X, and plus this looks like C. It looks like Y equals minus mx plus C graph. Y equals mx means something like this. Y equals mx plus C means something like this. Y equals minus mx plus C means a graph like this. right? Okay. Genuinely raise your hands. No theory, ni. You revise it, okay? Boyle's law, theory wise, that's all. Then I want to teach you what is Charles' law. Then what is, I think, state equation, something I don't know. Whatever we learn today, everything is very clear answer. Up to now, everything is very clear, crystal clear answer. Okay. So we'll take a break. Now time is 8:42. We'll take a break around mm, uh right, right. Mm, okay. Uh Now time is exactly 8:43. Put how long you want, put reply quickly. How long you want the break? Reply. Quickly reply. Reply quickly. How long you want? It's not y equals minus, huh? Minus mx means something like this. This minus m is plus c. How long you want? Reply everyone. How long you guys want? Quickly. Reply all of you. I'm not asking a question. I'm asking how long you want. So time is 8:45. Come at 9 o'clock. Wash your face, drink something, eat something, come at 9 o'clock. Yes. Right. Okay. Right. Then Boyle's law story is completely finished. Nothing difficult. Everything is very simple. Uh, put your main topic. Put your main topic. Then the second law is Charles law. Second law will be Charles law. Charles law. How to spell? Okay. Charles. Charles. Charles's. Is it Charles's? Is it Charles's law? It's Charles law. Charles law. Charles's law. Next story, Charles law. C Charles. Charles. Charles's. Charles law. Charles law. Ah, it's Charles law. Charles law. Charles law. Okay. Now same story. Now we are talking about Charles law. Now write down. Write down. Blue color pen. Charles law states that. Blue color pen. Charles law states that. Charles law states that. Red color pen. Write down. Red color pen. The volume of stationary gas. The volume of stationary gas. The volume of stationary gas. Mass at constant pressure. Mass at constant pressure is directly proportional to is directly proportional to its absolute temperature. Absolute temperature. Highlight absolute temperature. Highlight absolute temperature. A different color pen write down. Different color pen write down. Absolute pressure means, sorry, absolute temperature means, write down different color pen. Absolute temperature means temperature measured in kelvins. Temperature measured in kelvins. Okay, right. Now, second story. Second story, look here. Second story. Okay. They say that volume of a stationary gas mass at constant pressure is directly proportional to its absolute temperature. Okay. Now, just consider now Consider there is a gas sample. Mass is constant. In Boyle's law, you maintain mass and temperature constant. But in this Charles law story, you want to maintain mass of the gas constant as well as pressure is constant. You want to maintain pressure same. In any scenario, any state, pressure must be maintained at same value. Mass must be maintained at same value. Then they tell that volume of the gas is directly proportional to the absolute temperature. Not the temperature, but the absolute temperature. Now I will draw my gas sample. Mass, simple limb. This time pressure is capital P. Volume is capital V. Absolute temperature capital T. Right now they mention in the theory, they tell, in the law they tell, when you maintain mass and pressure constant, then they tell volume of the gas directly proportional to the absolute temperature. That means when you increase the temperature, parallelly volume also increases. If you maintain mass and pressure constant, when you increase the absolute temperature, corresponding volume also increases. When you decrease the absolute temperature, corresponding volume also decreases. So this is direct proportionality. Am I correct? Previous Boyle's law gives kind of inverse proportionality between what? Pressure and volume. But here volume and temperature, direct proportionality. To remove this proportionality, we are using a constant. We can tell volume equals. That constant is capital K. Capital K into absolute temperature, capital T. Absolute temperature means, remember, temperature measured in kelvins. So this is what Charles law says. So what we do generally, we don't keep in this format. We keep on a previous law, also you can remember PV into K. Likewise, we subject K here. Then we can write down volume over temperature means always a constant. Always a constant. Is a story. Highlight the story. This story is highlight. Okay. Can understand. I don't need to go at deep and I don't want to explain. Don't want to go deep and don't want to explain. Okay. Write down. Write down. So we'll define again. Again, we'll define again. I think you know, yeah, you are really good at understanding these things. But write down simple limb means again, simple limb, write down mass of gas sample. Simple limb is write down mass of gas sample. Capital T, absolute temperature of gas. Capital T, absolute temperature of gas. Capital V, volume of gas. Capital V, volume of gas. Capital P, pressure of gas. Capital P, pressure of gas. Okay. Can understand? Next story. Now, this is the equation. V over T equals K. But mostly we talk about two different states. So therefore, we want to alter this equation, which is able to apply for two different states. Therefore, write down applying Charles law for two states of a stationary gas sample. Subtopic, write down applying Charles law for two states of a stationary gas sample. Applying Charles law for two stationary. Sorry, applying Charles law for two states of a stationary gas sample. Stationary gas sample. The next story. There is a gas sample. Mass is fixed, simple limb. Pressure is fixed, capital P. Okay. Mass, simple limb, pressure, capital P. This is the state 1. At state 1, the volume of the gas is V1, the corresponding absolute temperature T1. T1 is absolute temperature. Then what we are going, state 1, this is my state 2. In state 2, mass and pressure is same, simple limb and capital P. but corresponding volume and temperature different. Simple MP, but corresponding volume is V2, corresponding temperature T2, state 2. So you derive the equation quickly. You can do it. State 1, state 2. So now what can I do? Now I can consider state 1. I can consider state 1 and what can I do? I can apply Charles law. So when I apply CHARLES Charles's L, L means lower. So we know that equation. We know that V over T equals a constant. That means V1 over capital T1 must be equal to a constant K. Roman number 1. Roman number 1. Roman number 1. So you do it, it's not difficult. Okay. So then state 2 apply Charles law. When you're writing, probably write down Charles law. Charles LAW Charles law. In this case, V2 over T2 must be a constant. Volume is V2, the temperature will be T2. This must be a constant. Constant is K. Roman number 2. From Roman number 1 and 2, you know, we can write down what? From Roman number 1 and 2, we can write down. From Roman number 1 and Roman number 2, we can write down an important equation. V1 over T1 must be equal to V2 over T2. We can write down the important equation. V1 over T1 must be equal to V2 over T2. Important equation. It's very important. No? Really important. Sample question. SQ. Story is easy. Boyle's law means you want to maintain temperature, mass. Mass is always constant. No matter whatever the law you learn in this lesson, mass is always constant. But depending on the law, you want to maintain another parameter constant. In Boyle's law, you want to maintain what? Temperature constant. But in Charles' law, you want to maintain pressure constant. So likewise, depends on different laws, you want to maintain different parameters constant, but always mass is constant. SQ write down. SQ, still we can't do two questions. Now that's why we are doing sample questions. SQ write down SQ. SQ, the temperature and volume of gas in a container. The temperature and volume of a gas in a container. The temperature and volume of a gas in a container. At a constant pressure R. At a constant pressure R. 400 Kelvin and 2 meter cube. 400 Kelvin and 2 meter cube. Full stop. When the volume is 10 meter cube. When the volume is 10 meter cube. Comma. Find the temperature. Find the temperature. In Celsius. In Celsius. In Celsius. Find the answer. Find the answer. Not difficult, but sometimes you don't know how to convert given temperature from Kelvin to Celsius. You don't know the conversion. I will teach you. If you want to convert Celsius into Kelvins, how to do. If you want to convert Kelvins into Celsius, how to do. I will teach you. You don't worry. Okay, you don't worry. Get the answer. Get the answer. SQ. So I want to do apply, you know, it's Charles law only. We know that V1 over T1 equals V1 over T1 equals V2 over T2. Okay. Initially that gas sample. What is the state? The pressure. Yeah, okay. They have mentioned what? They have given the absolute temperature 400 Kelvin, volume is 2. Then V1 is 2 meter cube. Then the corresponding temperature is 400 kelvins. So you want to find the temperature T2, but now volume is 10 meter cube. You want to find the now temperature T2. So you want to find T2. So when you subject T2, you know that your T2 will be how much? Your T2 will be how much? And now cross multiplication. 2T2 equals 4000. Then your T2 will be how much? 2000 Kelvin. But they are asking us to find the final answer not in Kelvin but in Celsius. But remember, I will tell you, if they have given a temperature in Celsius, normally the symbol is like this. And if you want to convert to Kelvins, symbol of Kelvin temperature is capital K. Then remember, if they have given the temperature in Celsius, if you want to convert to Kelvins, remember, you want to add what? You want to add 273. You want to add 273. At 273. The opposite is what? Then the opposite is what? If they have given the temperature in kelvins, if you want to convert Celsius, subtract 273. If they have given the temperature in kelvins, if you want to convert to Celsius, subtract 273. Subtract 273. So now story is very easy. A story is easy. Story is easy. Now we can write down the final answer will be how much? 2000. Now I know the temperature in kelvins, but I want to convert to Celsius. Then I want to subtract 273 from 2000. So then my final answer will be how much? Then final answer will be T2 will be how much? My T2 will be 2000 minus 273. So then we know the answer will be how much? 273 means how much? 73 means 280, 280, 300. 27. Am I correct? If I'm not, tell me. 273 means 280, 300. 300. Correct me? Hands up over this answer, hands up. This answer, hands up online. This answer. Got the answer? Easy. Very easy. Very easy. Very, very easy. Okay. Now what you do, now this story is done. Now again, we are going to talk about the graphs related to Charles law. Now we discussed about graphs related to Boyle's law. Now we are talking about the graphs related to Charles law. Graphs. Okay. Right. Okay. Anyways, write down a small theory points. This is write down units to measure temperature. A small topic, units to measure temperature. SI unit, Kelvin, capital K, ELVIN, Kelvin, inside the bracket, capital K symbol. Subtopic is units to measure the temperature. SI unit, arrow and write down, Kelvin, capital K, ELVIN, Kelvin, inside the bracket, capital K. Other units, write down, other units, Celsius, CELCIUS, Celsius. So you can keep that name for your daughter when you have a baby, Celsius. For a boy, you can keep Fahrenheit. Symbol is this one. Inside the bracket, symbol is this one, right down. Other unit is Fahrenheit. FAREN, HEIT, Fahrenheit. FAREN, HEIT, Fahrenheit. Symbol is this dot capital F. This dot capital F. Okay. Okay. Right. Now, finish writing, hands up. If you finish writing, hands up. If you finished, hands up. If you finished, hands up. Hands up. Right. Now, write down the topic, the graphs related to Charles law. Graphs related to Charles law. Graphs. First one is between V and T. Find the answer. Find the graph. To the graph. Graphs. Number one is between V and T. Graph between V and T. Take your y-axis as V and take your x-axis as T. Now remember, this temperature is measured in kelvins. Huh? This temperature measured in kelvins. Volume measured in meter cube or something, whatever. To the graph. To the graph. So in this case, normally the thumb rule is, before you plot a graph between two variables, first of all, somehow find an equation involving those two variables. If you want to plot V and T graph, you should know an equation involving V and T. So the equation that we know already, we know that equation involving V and T is V over T is K. V over T is K. So I write on that equation, we know V over T equals K, but we know my y-axis is V. I substitute V, then V means we know K dot capital T. Then my y-axis is volume V. This is my Y. My x-axis will be the temperature measured in kelvins. That is my X. This K behave as the gradient simply. So then my graph will be Y equals mh graph. Graph number 2. Can you understand? Graph number 2. Number 2, right? Number 2. Between V and write down between V and T, inside the bracket temperature measured in Celsius. Again, you are plotting the graph between V and T only. Inside the bracket, write down temperature measured in Celsius. Inside the bracket, temperature measured in Celsius. Draw the graph for the story. So your y-axis is V, but your x-axis will be temperature measured in Celsius. To the graph. To the graph. Again, obtain the relationship between V and T, because we know that V means we know. V means we know V equals KT. From the Charles law, we can tell volume equals K into T. But remember, Charles law is telling this capital T means not just the temperature. Charles law is telling this capital T means temperature measured in Kelvin. This T means, don't misunderstand, temperature measured in kelvins. Okay, therefore I put it as TK. Yeah? It's T only. TK means temperature measured in kelvins. But you are going to plot a graph. Your x-axis is the temperature measured in Celsius. Then you can write down V equals K. Temperature measured in Kelvin means you can write down. TK means what? How do you convert temperature measured in kelvins into temperature measured in Celsius? How can you do that one? Now you know that. How do you convert TK to TC? Kelvin to Celsius, you want to subtract. So what you want to do? Okay, no. So if you want, now you can tell now you know temperature measured in Kelvin means you know Celsius temperature plus 273. Am I correct? Remember, Kelvin temperature means temperature measured in Celsius plus 273. Am I correct? Temperature measured in Kelvin means temperature measured in Celsius plus 273. So they have a substitute instead of TK, substitute TC. TC plus 273. TC plus 273. Yeah, now finally my x-axis is TC. Now what you want to do? Substitute V. V means expand the bracket. K temperature measured in Celsius plus K into 273. And now you can know the graph. Y-axis represents volume. Y-axis is volume equals temperature measured in Celsius is my x-axis. K look like my gradient plus this entire setup look like my interception. Then my graph is look like y equals mx plus c graph. How can you draw y equals mx plus c graph? Something like this. Y equals mx plus c graph means something like this, right? If you extend to this side. Okay. But I want to ask you questions. Hands up. Up to now, stories easy answer. Hands up. Up to now, stories easy answer. Stories easy. Hands up. Stories easy. 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 Right. Okay. Now look here. That's an important point. In this graph, sometimes they can ask you in exams. They can ask what is the interception. You know, interception is 273 into K. Am I correct? Now, don't you misunderstand? This K means not Kelvin. Huh? This K means I put as K dash because you confuse. K dash. Then your interception means remember. This gap means remember. This is, even this gap is remember 273 into K dash. Okay. I will ask you one question. Can you tell the temperature at this point? If you know, someone tell me. Put in chat box. If you properly look at the graph and tell me what should be the temperature at here. What should be the temperature at here? Any idea? Based on these values and this equation and tell me. Now at this point, you want to find the temperature. Look at this equation. This equation. Now at this point, someone tell me what is the volume? Reply someone. At this temperature, I don't know this temperature. I don't know this temperature. Actually, I don't know this temperature. But I know at this temperature, what is my volume? My volume is 0. At this temperature, my volume is 0. Volume is 0. I want to find this temperature. Put 0 here. Put 0 here. Then 0 over K dash means 0. 0 equals Tc plus 273. Then tell me what is the temperature. Tell me what is the temperature. Reply someone. Reply everyone. Any idea? Quickly reply. Then this temperature will be remember. Remember. Then you know, from this equation, I can write down now volume is 0 at the temperature. K dash Tc plus 273. Am I correct? Actually, I want to find the temperature Tc only. When the volume is 0, what is the temperature? I want to find Tc only. When I simplify it, 0 over K dash means 0. So therefore 0 equals Tc plus 273. Then you can write on Tc as what? Minus 273 Kelvin, sorry, minus 273 Celsius. Important, huh? This is important. So therefore remember, this is minus 273 Celsius. This gap is, remember, 273. Okay. Okay, very important, huh? Charles law is finished. Charles law is finished. Right, we started with Boyle's law, we started with Charles law. Now you understand the pattern. There's a pattern. Every physics scenario, there's a pattern. The most difficult thing is understanding the pattern. If you understood the pattern somehow, if you know the sums, if you know how to do simplification, That comes from your O-level knowledge. How much you developed your simplification skills throughout your O-level period, and you can master in A levels. Even you could not do simplification in O levels, you can master in A levels also. Then, if you know how to do the simplification, after reading a question, if you can understand the concept, the pattern, then you want to go in a smooth flow. Automatically get the answer. Answer. Time is 9:30. We started at 7:15, 8:15, 9:50, 9:30. Okay, Charles Close story, that's it. Charles Close story, that's it. Right. Okay. Now what is the plan? Now the plan. Now the plan is pressure law. Next law. Now we have already discussed two laws. The next law is pressure law. Now you know what is the story. Someone tell me Boyle's law. All the laws I told you, mass of the gas must be constant. Boyle's law, we maintained whom constant? Temperature. Charles' law, we maintained whom constant? Pressure. Someone tell me in pressure law who is going to be constant. Someone tell me in pressure law who is going to be constant. Someone tell me in pressure law who is going to be constant. Volume. Right? Write down pressure law and write down pressure law. Now quickly write down pressure law. Write down. Blue color pen. Pressure law states that. Blue color pen. Pressure law states that. Red color pen. Write down the pressure of stationary gas mass. The pressure of stationary gas mass at constant volume. At constant volume is directly proportional to is directly proportional to is directly proportional to its absolute temperature. Its absolute temperature. Highlight absolute temperature. Highlight absolute temperature. Okay. Okay. Now story is again draw. Now this time look here. Pressure law. Pressure law. Pressure. Then we maintain mass always constant in the gas, and we maintain this time volume constant. Then who is going to vary? Now mass and volume constant means who is going to vary? Pressure and temperature. If you maintain volume constant, who is going to vary? Pressure and temperature. Okay. Then you can write down when mass and volume constant, you can tell pressure directly proportional to absolute temperature. When temperature increases, pressure increases. When temperature decreases, pressure decreases. So therefore, you can write down a proportionality. Then this is the proportionality. Then you can tell pressure equals constant T. That means P over T means V naught K. Story done. Write down. Write down. Then write down the heading, right? I'm not going to do it. I have no mood of telling that. Okay. So you know the heading. Then thereafter the heading is what? Thereafter the heading is what? The heading is applying pressure law for two states of stationary gas mass. Applying pressure law for two states. Applying pressure law for two states of a stationary gas sample. Again, this one. Mass and volume constant. State 1 pressure is P1, temperature T1, absolute temperature. Mass and volume constant. Pressure is P2, temperature T2, state 1, state 2. Pressure low. Pressure low. Pressure L for low. Pressure low. Pressure low. P1 over T1 equals key. P2 over T2 equals key. Finally, P1 over T1 equals P2 over T2. Okay. This no, don't do anything for here. Finished writing hands up. If you finish writing hands up. If you finish writing hands up. Very simple. One finished. Rewrite the story. But when you always I say that when you maintain a knot, maintain a proper knot, good knot. Okay. If you finish writing hands up. Okay, now I advise you guys to join the revision class because we are discussing papers from this month. So I give 1 month time period because I next month onwards I will send the papers also in the first week itself. Okay, give me 1 month, not 1 month. I try in the middle of the February. I try to post them properly. Dude's already posted, but papers everything I could not post. So we'll plan everything properly and we'll work. And parallelly, I want to start Unit 5 also. Okay. If you finish, answer. If you finish, answer. One finished. Done. Then write the topic. What the topic? The topic is graph related to pressure law. Graph related to pressure law. Number one. Number one. Number one. Between P and T. Between P and T. Same story. Number two. Between P and T. This time temperature measured in Celsius. Between P and T. This time temperature measured in Celsius. Only difference is pressure is zero. At this point, pressure is zero. Then P equals then P equals done. Same. Finish writing answer. Finish writing answer. If you finished answer. But today I think mainly I try to finish the theory as soon as possible. Next day we'll do questions. This extra class on February 4th. Once you finish writing, it's hands up. Done? Right? Okay. Story finished. Now you understood Boyle's law, Charles law, and pressure law story. Now you today what you do after class finishes, take half an hour time, and what you do today, whatever the theory that we discussed. What is mainly important? Now in the beginning I told you how this gas pressure forms. I took a long time and I explained some stories. That the reason behind that is sometimes they are not important, but to understand what's happening here, in order to make you feel what is gas pressure, I have to explain everything in depth. But when we do a question, in the end, when you do a question, all those explanations are not important. Now, so far, what is important? Only these three laws. You don't want to remember the definition also. They are not going to ask, rather than the structured essay questions, they are not going to ask the definition of Boyle law. What is Boyle law? What is Charles? What is special law? They are not going to ask. Okay. So, what you do today after class is just take a small time, half an hour or whatever, brief it. What is mainly important from today's lesson? Half page, right? For not full paper, half paper, everything beautiful, use beautiful color pens, half page, include everything. Today, I think you might have written for 2, 5, 6, 6, 7 pages. You want to brief into half page because that is important when you go for exam, right? Because these short notes are very important. Many students from my 24 batch students they told that short notes very important. It was very useful before the last month of the exam. They used that short notes and they could quickly they can recover in front they can quickly they can cover them, they can revise them. So therefore may start writing short notes from now. 9:45. Now the next law is combined gas law. This is important. Put your main topic, combined gas law. Main topic, combined gas law. Okay, combined gas law. Okay, right. So write with me. So draw with me. Okay, draw with me. Now I'm going to draw three pistons. So you also draw three pistons. Combined gas law. Combined gas law. State 1, state 2, state 3. If not state 1, intermediate state, state 2. State 1 mass is simple name. Pressure is P1. Mass simple name. Let's say pressure is P1. Then the corresponding temperature and volume of this gas sample. Volume is V1. Temperature is T1. So this is state 1. Okay. State 1. Now, state 1 to intermediate. I will explain. You don't worry. I will explain. First of all, you do the diagram. Boils. Boiles. Boils. I will tell you. Don't worry. I will explain. Mass and temperature constant. State 2. If not intermediate state. This is the intermediate state. mp2 v dash t1. Same mass, but we know pressure is now P2. Now Boyle's law means, okay, I will tell you, pressure is P2. Then temperature is same as T1, but volume is now V dash. Volume is V dash. Charles law. Charles. That means mass and what is constant? Mass and pressure constant. mp2 v d2. m p2 v d2. So this is my intermediate state. IM. IM means now when you are writing this one, you don't just write IM state because after many months later, when you look back the note, you don't know what is IM means. Industrial manager. Intermediate state. Intermediate state. Okay. Intermediate state. IM state means intermediate state. You write properly. Yeah. IM miss. Okay, got it. Next one, state 2. State 2. Okay. Now this is the story. Okay, now listen now. In order to maintain a good theory, not only I'm explaining this much. Okay, here. Now, when you compare Boyle's law, Charles law, and pressure law, we maintain always mass constant. Based on the law, one variable we maintain constant. If it is Boyle's law, we maintain what constant? We maintain temperature constant. If it is Charles law, we maintain pressure constant. If it is pressure law, we maintain volume constant. Then we take the relationship between the remaining two variables. Boyle's law relationship is what? Pressure and volume. Charles relationship is what? Volume and temperature. Pressure law relationship means what? Pressure and temperature. Okay, that is the story. So always the relationship was only between two variables when you consider Boyle's law, Charles law, and pressure law. But in this combined gas law, remember, when the mass of a gas is constant, it gives the relationship between the three variables. When the mass of a given gas is constant, it gives the relationship between the three variables. Let's say now in state 1, mass is simple m. State 1, pressure is P1, volume is V1, temperature is T1. State 2, pressure is P2, volume is T2, and temperature is in state 2, pressure is P2, volume is V2, temperature T2. It gives the relationship between pressure, volume, and temperature. So all the previous laws, it gave the relationship between two variables. Now this combined gas law gives the relationship between three variables. If you maintain mass only constant, how the remaining three variables involve? How the remaining three variables vary? That is the idea. To get that derived, to get that equation only, what we do see, mass is constant. Mass always constant. Mass always constant. Okay. Now, just think now initially in state 1, pressure is P1, volume and temperature. Temperature is absolute temperature like that. Temperature is absolute temperature. Then volume and temperature all are same. The volume and temperature is V1 and T1. Pressure is P1. Okay. Now, state 2 means same mass, but this time pressure is different, volume is different, temperature is different. What's my goal actually? I want to obtain an equation P1 V1 T1 P2 V T2. I am going to obtain an equation involving P1 V1 T1, P2 V T2. That's my target. This is what, if you can obtain the equation between state 1 pressure volume temperature and state 2 pressure volume temperature, then that is the gas law equation. Now, how do we get that equation? That's the problem. How do we get that combined gas law equation? How do we get? So that's why I have taken kind of intermediate medium. In intermediate medium, you notice, look here, in intermediate medium, you noticed, see, in this intermediate medium, mass is same, state 1 and intermediate medium, mass same, temperature same. Am I correct? But what happened? What has changed? Pressure changed from P1 to P2, corresponding volume change from V1 to V dash. Then you understand what happened. Now you are state 1 to state 2, Boyle's law. State 1, state 2 obeys Boyle's law. Because we know when mass and temperature constant, P1 V1, you know that P2 V dash, P2 V dash. Okay, right? My target is to obtain equation involving P1 V1 T1, P2 T2. As a first step, when I consider state 1 and intermediate state, I can write down carefully, right? Listen, I can write down applying Boyle's law for state 1 and intermediate medium. I'm applying Boyle's law. Boyle's law for state 1 and intermediate medium, IM. Then what you can write down? You can write down. What is the Boyle's law? You know, Boyle's law means P1 V1 equals P2 V2. Now, don't you misunderstand that equation P2 V2 when these two stories are. If not, I don't write down P1 V1 equals P2 V2. Directly I write down Boyle's law means P1 V1 equals here P2 V dash. Am I correct? This I take as Roman number 1. And I consider again, look here this story. When I consider intermediate state and state number 2, think this as an imaginary state. Then in these two stories, mass constant, pressure constant, P2 P2. But volume changed from V dash to V2, temperature changed from T1 to T2. Then it obeys what? Charles law. It obeys Charles law. If I apply Charles, CHARLE, if I apply Charles law, for whom? I intermediate medium and and state 2. Then I can write down what? Then I can write down V dash over T1, right? V dash over T1 must be equal to V2 over T2. This is my Roman number 2. What's my target? My target is to obtain an equation involving P1 V1 T1, P2 V2 T2. I took 2 equations. I took 2 equations. Then what I thought is from my Roman number 1, Roman number 2, what I thought. Now I can write down something like this. Look here. I can write down what will happen if I multiply. Now there are different ways to get the final equation. You can go with addition. No, you can go with division. You can subject V dash. You can go with different options. But I thought of multiplying Roman number 1 and Roman number 2. So you can go with your different ways to get the final equation. Anyhow, you get the same one. I thought of multiplying Roman number 1 and Roman number 2. Then we can write down P1 V1 into V dash over T1 must be equal to P2 V dash into V2 over T2. V2 over T2 is the final. Finally, who's get cancel out? The people who get cancel out. Who's getting cancel out? See, V dash cancel out. Am I correct? Finally, this V dash cancel out. Finally, I'm getting my final equation as P1 V1 over T1 equals P2 V2 over T2. This is the combined gas flow equation. Finally, we are getting the important equation. Remember, P1 V1 over T1 equals P2 V2 over T2. So why do we name it as combined gas law? Because this scenario, the conversion from state 1 to state 2 happens with the help of two gas laws, Boyle's Charles, combined. That's why we are calling it as combined gas law. Remember in the question, if you notice, if they have given only mass is constant, if other variables are varying, pressure, volume, and temperature all are varying, if mass is constant, you apply combined gas law. You apply combined gas law. Four laws done. Done. Genuinely hands up. Did you understand? Hands up. Hands up if you understand. Hands up. Understood. Hands up. Understood. Okay. Finished writing. Raise your hands. So this means remember combined gas flow means remember pressure into volume over T means always a constant. So write this also. Pressure into volume over temperature means always a constant. This story. Okay. Right. So then the last one. Now today is theory only all what we don't discuss any question in deep, but it's okay. Now then, if we finish this doing Dalton's partial pressure law, then story finished almost finished. Not yet fully finished. Uh, now write down the story. Then ideal gas equation is there. Oh god, there are many. Why this much long? This is okay. Put your main topic. Dalton's law of partial pressure. Dalton's law of partial pressure. Dalton's law of partial pressure. Write down. Write down. I will explain. Don't write down. The total pressure of a gas mixture. The total pressure of a gas mixture is equal to the total pressure of a gas mixture is equal to the sum of the pressure, sum of the pressure, sum of the pressure exerted by sum of the pressure exerted by each constituent. I don't know what is that word meaning actually. I am really poor of English knowledge. Each CON is cons TIT UENT. CO1 is cons TIT UENT. Okay, each constituent gases individually under the under the under the original temperature and original volume. Under the original temperature and original volume. So when I tell like that, you don't understand. Under the original volume and original temperature. Or there's another definition. Okay, or means a different line. Next line write down or, and next definition write down. Next definition: total pressure exerted when a mixture of gases. Total pressure exerted when a mixture of gases. Total pressure exerted when a mixture of gases are contained in a vessel. Are contained in a vessel. Are contained in a vessel is equal to the is equal to the is equal to the sum of the pressure exerted by each gas. Sum of the pressure exerted by each gas when they are placed in the same temperature and volume. When they are placed in the same temperature and volume. Okay. Now this story, how can I teach you? Dalton's pressure, partial pressure law. Okay. Now looking at the story. Now, now up to now, careful listen. Up to now, we talked about Boyle, Charles, pressure, combined gas law. All this law, we considered only one gas sample. When there is a gas means when there is hydrogen, when there is nitrogen, when there is air. Generally, but now let's say now if there is a gas mixture in a container, you know the volume of the container, let's say capital V, and you know the temperature inside the container is capital T. Then the temperature of the gas mixture also capital T. Now just think, in the gas mixture there are oxygen, nitrogen, hydrogen, for example. In that gas mixture there are three types of gases. Oxygen is there, hydrogen is there, nitrogen is there. Okay. Now you want to find the total pressure produced by all three gases under that volume V and under the temperature T. How do we do this one? Okay. Right, carefully listen. Dalton told something, I will tell you. Carefully listen, this is a very important story. Because the complex story is this Dalton's pressure, partial pressure story. The remaining are not complex. You understood me? Dalton. So why this Dalton introduced many laws for hitching? He introduced and he went. Now we only suffer. Dalton's law. Now consider a container. Consider a container. Just think, there are three different gases in the container. There are three different gases. I use different symbols to represent these three different gases: oxygen, nitrogen, let's say hydrogen. And then hydrogen means then what? I use right. Okay. Wow. Okay, give me a second. Okay. Right means the different gas. Okay, Dalton told something like this. Now, when there are many gases in a container. Now in this story there are three gases, right? Red, blue, and black. The total pressure under the volume capital Vn, under the temperature capital T. Let's say the total pressure is Pt. The total pressure of the gas mixture will be Pt. Dalton told this mixture gas pressure equals to take the same container, that means same volume, and maintain same temperature. Okay, maintain same temperature. Wait. Dalton told that if there is a gas mixture in a container under volume V and temperature T, that pressure of the gas mixture equals when you remove the gas mixture and when you place, there are three gases in the mixture, right? When you place one gas in that container, that means under that same volume and same temperature, when you insert one gas, let's say black color gas, then black color gas creates kind of pressure. I say the pressure produced by the black color gas under same volume and same temperature is P1. You should understand the mixture. Say under same volume and same temperature, gas mixture's pressure is Pt. If you only insert only black color gas under same volume, same temperature, black color gas creates P1 pressure, because you should understand P1 should be lesser than Pt. Okay, then what you do then, remove this black color gas and again put this red color gas under same volume, same temperature. Then pressure produced by the red color gas is P2. Remove this red color gas out and again put this blue color gas inside the container. Under same volume, same temperature, pressure produced by the blue color gas is P3. Dalton told that under that volume and temperature, gas mixture's pressure equals the summation of each gas pressure under that same volume and same temperature. Do you understand? Hands up who understands the story, hands up. Hands up who understands the story, hands up. Story. So write down PT means finally P1 plus P2 plus P3. Okay, you're tired. Mood of sleep. I want to go and sleep. Finish writing. Are you? Why this much hard teaching? Teaching good, but no crowd. How pathetic my story. Okay. Today, I thought of wind up. Hands up. Whatever we learned today. Crystal clear. Hands up. Crystal clear. This is like nothing. Crystal. Great. So what you do? We are doing day after tomorrow also extra class. What we do now? We'll go and sleep. Okay. So now, okay, don't go and sleep. First of all, you prepare a short note and have your dinner or whatever, and send the short note and sleep. Huh? I'm stopping now. Tudes are sent tomorrow. Sometimes you will get everything. Okay. Have fun. I'm stopping the class. Have fun. Please recommend us if you are friends planning online classes. Have fun. Bye bye. See you.